Okay, welcome Nehal and welcome Ricky. We are back again with another episode of Business Analytics on the Blockchain. Um, what are we talking about today, Ricky? We're talking about DAOs, decentralized autonomous organizations. Is that right?
Correct. So today we're following up on part one about DAOs. So in part one, we discussed DAOs at a really high level, and today we're going to build on that knowledge and looking at actual on-chain data that we pulled through the graph.
Very cool. Take it away.
Awesome. Yeah, let's jump right into it. All right, so for today's analysis, we'll be diving into the question of how centralized the decision-making power is in practice today across a number of different DAOs. So for this analysis, we are relying on subgraphs developed by Messari. As we've discussed in previous episodes, their team has done a really amazing job in creating these standardized schemas for subgraphs, which are really useful for analytics use cases, especially. So a lot of blockchain protocols are really similar to each other. So for example, for governance, for maybe many protocols that utilize very similar structures and smart contract templates, but when the data is extracted, it could have really different format between the two. So with these Messari subgraphs, we can figure out which protocols fall into a particular type and schema and basically category. And we can run the same exact queries and analysis for all of the protocols that fall into those categories. And while that's really great, there's also a lot of nuance in how different DAOs operate. So we are limiting ourselves to a smaller subset of DAOs that operate within similar frameworks that are covered by Messari. And we're certainly not covering even close to all DAOs that exist today. But we do have a couple of the big ones that we'll be looking through today. So let's quickly talk about how protocol changes are actually made through voting in a DAO. So one of the ones that Messari covers is called Aave, which is the largest money lending protocol in Web3 today at over $6 billion in total value locked within the protocol. So if you're a new project in the space and you want to develop a DAO, you may actually lean on a proven project like this one and essentially just make a copy of what they're already doing and kind of turn it into your own DAO with your own token rather than kind of reinventing the wheel, since it is a proven thing with a lot of value locked behind it. So in the case of the protocols we're covering today, the governance structure will typically look something like this, which actually is how governance for Aave generally works. So basically first, we have users who will typically have open discussions inside of these dedicated forums for a given protocol. And once there's been some discussion and there seems to be enough consensus that this is a valid proposal that has some merit, it will typically become formalized into what we call an improvement proposal for the protocol. Sometimes there may be some like off-chain polls, which we won't really talk about today, but the next meaningful step here is to basically bring this proposal to a vote on-chain. And then if this vote passes, the protocol has a change that is actually implemented on the blockchain, as long as there's kind of some requirements met around like minimum voter participation and things along those lines. So to kick things off, we can first just look through some very high-level statistics that we've pulled for each protocol through their subgraphs. So for example, we can see the total number of token holders for each protocol, which can start to give us a sense of how the different DAOs compare to each other in terms of their size. So here we can see that Optimism, Uniswap, Compound, and Aave have a fair amount more tokens than other protocols that we're covering here today. So they tend to be larger, more well-known projects. So next we can see the number of on-chain votes for each protocol. And here we can see, Optimism is really ahead of everyone else by a pretty large margin. And another thing that really jumps out as being interesting based on these two charts alone is the difference between the number of token holders and the people that are actually participating in voting on-chain for a given DAO. So for example, if we go back here, we can see that Compound has over 211,000 token holders, but only 8,700 votes were ever actually recorded on-chain for these proposals, which is really low voting participation for the number of token holders for this project. And we can also kind of drill down into that further with this next chart, where we can see that Compound actually has already had 122 different proposals So these 8,700 votes are actually spread really thin relative to a number of token holders that would be affected by this decision made through this governance process. Another thing we can do on this chart is we can toggle it by status. So we can basically see how many were actually passed versus canceled. So this analysis, as we've already talked about, will be focused around measuring the level of inequality that exists in DAO voting mechanisms. So before we really get started here, I'm going to give a quick overview of something we call the Gini coefficient. So this chart might feel a bit overwhelming at first, but it should make a bit more sense after we explain it here. So basically what we have is on the x-axis, we have the cumulative percentage of the population. And on the y-axis, we have the cumulative percentage of the income earned by this population. So what this means is that in a perfectly equal world, the top 1% of the population would make up 1% of the total income. But of course, in reality, the richest 1% of the population earns a lot more than the poorest 1%. So the more dramatic the level of inequality, the more this blue line will move away from this red perfect equality line on this chart. And we can then basically look at the area between these two lines, which is labeled A on this chart, and look at the proportion of A relative to all of the space under this red perfect equality line. And this is essentially what we call the Gini coefficient. So to kind of give more context behind that, so if A made up the entirety of the area, that would mean that the top 1% makes 100% of the income. And we basically have a Gini coefficient of 1. While if we had a perfect equality, the Gini coefficient here would be 0. So basically, the higher this number is, the more inequality exists in the system. Also, just to kind of get some terminology out of the way, the chart itself is what we call a Lorenz curve, while the proportion made up by the area of A that we just talked about is the Gini coefficient. So the Gini coefficient is kind of the actual number that we're interested in here.
And Ricky, why do we care about this? We care about it because we want a voting protocol that's fair, is that it?
That's a good question. So while the Gini coefficient is useful because it helps us quantify and kind of standardize the level of inequality, why do we care about inequality within a voting mechanism is because a lot of these systems are kind of selling their users on the idea of being able to have a say in what actually happens in these protocols and aligning the incentives between the users and the protocol. So we essentially want to create a framework that lets us evaluate whether this is actually taking place or whether this is kind of more of a marketing tactic to attract capital from people.
So if a DAO had a Gini coefficient somewhere between 0.9 and 1.0, you buyer of the token may not get a lot of impact or voting power, is what you're saying?
Correct, yeah. And that's actually a really good segue into the next point, which is what kind of baseline can we establish here in terms of making this Gini coefficient more interpretable? So what does it mean, right? If a Gini coefficient is 0.9 or 0.5, right? So as a point of comparison for us to evaluate these systems, we can compare these to real US data. So when we look at the distribution of income within the United States, we get a Gini coefficient that's around 0.49, which is actually a lot better than what we get if we look at the Gini coefficient of the net worth within the United States, which is 0.85. So hopefully these two numbers kind of give us a frame of reference when comparing the Gini coefficients for DAOs. One of the more interesting parts here can also be just comparing different DAOs and how they compare to each other as well. All right, so when we look at this in the context of DAOs, we can't simply look at the balance of the token holders themselves and just easily calculate the Gini coefficient. So one of the main reasons is that there's a lot of centralized exchanges, which basically hold on to a large amount of the tokens on behalf of the users. And they technically could vote on these proposals in these DAOs, but typically they abstain from the votes. They don't participate in governance. But centralized exchanges and other entities controlling large amount of the tokens can actually be potentially problematic. There is a lot more to unpack on this point in particular, but we'll kind of leave it at that for now. Another area is the fact that things can get really murky when we look at token balances alone on chain due to how some of these staking contracts, so these smart contracts that allow users to lock their tokens, they can work in pretty dramatically different ways. And there's like a lot of different scenarios to account for. Yeah, so these are the main challenges that prevent us to simply look at token balances and calculating the Gini coefficient that way. And we can actually kind of show this. So just to kind of show those points, we can take a look at what the Gini coefficient would look like for the token balances as a whole. So yeah, basically for the reasons described, we can see that we end up with values really close to 1. So, I can change this to a number of different protocols, but it's essentially going to be 1, which would basically tell us that it's completely controlled by, one or few entities relative to how many actual participants there are. But again, that's because of the factors that we talked about in the previous slide. So yeah, we either basically need to account for all of those things for each protocol, which can be very, very challenging, or we basically need a slightly different way of looking at this. So instead of taking that approach, we can look at the Gini coefficient of the voting power that users had on any given proposal that they voted on. And we can see that things start to look a lot better when we compute it this way on individual proposals. And another thing worth mentioning here is that each protocol will tend to have a front end that facilitates users to vote on these proposals on chain. So any of these proposals we could actually find on their site, and we can see that there's all these executed ones. And within here, we could take a look at the proposal in full, kind of the things that it's proposing on changing. So we can see it's changing these parameters. And then we can also see how people have voted on this given proposal. But, instead of going one by one here, what we're really interested in is the more global picture of how things look. So what we can do is we can find the median Gini coefficient for all of the proposals for each protocol. And then we can basically compare this median taken across all the proposals and compare different protocols between each other. So here we can see that some protocols like Gitcoin have really extremely centralized decision-making power on most of the proposals being voted on, while other protocols like Aave are pretty comparable to the distribution of net worth within the United States, like we talked about before. And then we have a couple other ones that are smaller, but are actually doing quite well with Gini coefficients around the 0.3 mark, which I would say is actually quite good. So yeah, all in all, although not perfect, DAOs, as we've discussed in both of these videos, are this really promising tool for managing protocols that even in these really early iterations are being used pretty effectively to successfully pass many hundreds of proposals and changes with better aligned incentives and participation by the users themselves relative to what we see in kind of more traditional organizations. Yeah, that's kind of all I had for us today.
Very nice. Good job.